Hi friends, we were discussing about the lecture video on the factor of safety. In the previous video we learnt about the effects of the ice and then the wind pressure, and that acts on the conductor. One acts vertically downwards and the other acts horizontal direction. So the resultant will be the total acting weight that is acting on the conductor in the severe weather conditions. So we understood that the vertical sag is nothing but the cosine component, that is S into cos theta, and similarly we understood about the slant sag also. Now moving on further, what is factor of safety? We know that every conductor will have a certain ultimate strength and beyond which it is going to result in the breaking stress. And so the factor of safety can be defined as the ratio of the breaking stress to the working stress, or it can also be defined as the ratio of ultimate strength to the allowable working tension T. Factor of safety do not have any units because it is the ratio of its own expressed in both the same units. So we understood about the factor of safety, we understood about the vertical the effects of the wind and then the ice coating. So after this we can calculate for certain conditions we can always calculate what is going to be the factor of safety and what is going to be the breaking stress and what is going to be the maximum sag with the different data that is given. Here I have solved some of the numericals. We can refer it later and then we can calculate and then we can understand for the given conditions what is going to be the sag. I have taken the examples of different case studies and we have calculated the sag for the different conditions also. The most important part of the conductors which is going to get affected are the vibrations. Now we will consider the vibrations of the conductors and then how we can reduce these vibrations, which is going to cause a lot of concern in the overhead transmission lines. So here if we consider the conductors are supported by the string insulators and at each tower. So the function of the insulator is nothing but it is going to give the protection give the protection to the conductor, which is the live conductor, from the supports, and then the supports is going to get the separation from the live conductors. That is, it is going to protect the poles, and the conductor will not pass through the insulators, but it will separate the live conductor from the support. So now under this varying weather conditions, the insulators, the conductors are supported by the strong string insulators which are at either side, and it is going to experience the weather conditions, severe weather conditions. So this are going to give the support to the conductors with respect to the strong wind velocities, and then the conductors, if at all it experiences a strong wind velocities, the conductor can start vibrating mechanically in the vertical plane. Such vibrations can have different frequencies, amplitudes and the modes. So there are two types of vibrations which can be defined and then which can be considered for the discussion. The two types of the vibrations are: the first one, the resonant vibration or the airline vibration. Second one is the galloping or the dancing of conductors. Airline vibrations, let's consider the first one. And airline vibrations have the frequency range of up to from 8 to 40 hertz with the amplitudes varying between 2 to 5 centimeters. Thus these vibrations are of high frequency, low amplitude type of vibrations. The wind velocities are of 2 to 40 km per hour. Wind velocities can generate the airline vibrations, and the frequency of the airline vibrations is given by F alpha is nothing but equal to 2 into Vp divided by D into 10 to the power 3. Vp is nothing but the wind velocity in kilometer per hour, which is perpendicular to the conductor. D is the diameter of the conductor in meter. These vibrations are not much harmful, but if these vibrations coincides with the natural frequency, then the resonance may occur, and this is going to result in the breaking of the strands and mechanical failure of the conductors. From the suspension point of view, the airline vibrators are harmful. The airline vibrations travel along the length of the conductors, and then whether the clamps are used, wherever the clamps are used, it is going to restrict the airline wave. The conductors are going to be, the conductors momentarily bend because of the wave. So from the suspension point of view, the airline vibrations are very harmful. The airline vibrations travel along the length of the conductors wherever the clamps are used because of the obstruction that is caused due to the caused to the airline waves. The conductor will bend as the wave reflects back. The conductors are vibrated back and back and forth continuously, and as the suspensions due to the airline vibrations. This is known as the metallurgical fatigue. Now, galloping of conductors. The second type of vibrations is called galloping of conductors. Galloping means the dancing of the conductors at a low frequency, high amplitude. So these are the oscillations of complete span of the conductors. It causes the longitudinal movement of the conductors and longitudinal movement of the conductors through the conductor clamps. The frequencies of the galloping are about 0.25 to 1.5 Hz with the amplitudes of about 6 meters. This figure shows the three modes of galloping of the conductors. The first one shows that due to the amplitude A, the conductors are separated and then it is taking a different shape. Second one, the original position of the conductors, but it twists and then it shows the original position of the conductor, and the two conductors are overlapping each other. Two loops, it is forming the two loop. The continuing further, if it is too severe, then it is causing three loop on one overlapping the other one. So when the wind blows past the non-circular conductor, the galloping starts. The oscillations are built on their own, and then the galloping becomes very large. The path of the conductor is elliptical, or elliptical is galloping. So this can cause the flexure fatigue, and there is a possibility that the conductors may ripped off from the pin insulators. If the amplitude is large, more than the sag, then the clashing of the conductor with the earth occurs, and then the flashover may result. Galloping is very rare but may occur during the icing conditions because the weight is more, and then if the wind blows very fast, then this galloping may occur. In case this has to be taken while designing the conductors for that kind of regions where the ice coating is expected due to the seasons, and there we need to consider this kind of galloping also as one of the design consideration, and we need to give the proper allocation to it, and otherwise it affects the insulators, it affects the towers, it also affects the supporting accessories very badly. So whenever it occurs while designing the conductor, the amplitude of the possible galloping has to be considered, and as galloping vibrations are longitudinal, horizontal configurations of the conductors can avoid clashing of the conductors during the galloping. There is a vibration damper that is shown in the figure, which is called as a stock bridge type of vibration damper. It is normally seen on the high voltage lines, and then which is going to give the protection to the conductors against the damping conditions, that is the vibrations, against the vibrations of the conductors. This to control the airline vibrations, the stock bridge type of damper is used. However, we cannot restrict the galloping of the conductors completely. It consists of the steel cable. At the two ends of the cable, specific shaped weights are fixed. At the midpoint, the damper can be fastened to the conductors by means of the aluminum clamp. The weights that are used are of the galvanized iron. So the main feature of the damper is the grip of the damper with the conductor through one bolt. The vibrational energy due to the hysteresis loss and the interstand friction gets absorbed by the damper, and then the number of the damper depends on the length of the span and size of the conductors, locations where it is used. So the next factor that is to be considered in the overhead lines is the lighting. This lightning is nothing but the electric discharge between the cloud and the earth, or it can be between the clouds, or it can be between the charge centers of the same type of clouds. It is known as the lightning. So this lightning has got a severe effect on the conductors, and we need to understand the protection that should be given to the overhead line conductors. So here the dangerous surges are caused due to the lightning. The lightning surges travels along the waves and reaches the equipments of the power systems as the waves. Then this may occur either as the direct strokes on the equipment or on the transmission lines. It is necessary to provide the protection against both the type of surges. The most commonly used Now, the most commonly used devices for the protection of the conductors from the lightning are earthing screen, overhead ground wires, lightning arresters or surge diverters. Earthing screen provides the protection to power stations and substations against the direct strokes. Overhead ground wires protects the transmission lines against the direct lightning strokes. Lightning arresters protects the station from both direct strokes and as well as the stroke that is caused into the operators as the traveling waves. This is the overhead transmission line which is shown in the figure, and then it completely explains the lightning conductor and then what is going to be the action that happens during the lightning. In the figure, this is the most efficient and then the effective method of providing the protection. The ground wires are placed above the line conductors at such positions that practically all lightning strokes are intercepted by them. The ground wires are grounded at each tower or pole through the or low or resistance that is possible. Due to their proper location, the ground wires will take up all the lightning strokes instead of allowing them to the line conductors. The heavy lightning current 10 kiloamperes to 50 kiloamperes from the ground wire will flow to the ground. The degree of the protection depends on the footing resistors that is connected to each tower. The value of the foot resistance should be kept as low as possible so that it can bypass all the current through the protection system, so as to restrict the V1 is equal to I1 R1 to restrict the potential rise in the insulators. So now what are the advantages of this? Advantages are protection against the lightning strokes on transmission lines. A grounding wire always provides the damping effect on any disturbance traveling along the line, as it acts as a short circuited secondary. It provides a certain amount of electrostatic shielding also against the external fields. Thus, it reduces the voltages induced in the line conductors due to the discharge of the neighboring cloud. What are the disadvantages? Disadvantages are nothing but it requires additional cost because it has to run all along parallel to the overhead transmission conductors. There is a possibility of its breaking and falling across the line conductors, which is going to be dangerous, which may result in the short circuit of the conductors. And the usage of the galvanized standard steel conductors as ground wires seems to be the better one. So the overhead line insulators, the most important part of the component of the overhead the power transmission system is the insulators. Let's understand what are the insulators and what types of the insulators are going to be used for the different conditions, and in details we are going to discuss about the insulators. Line insulators are one type of insulators. They are used to protect the overhead lines getting in touch with the conductor. So it provides a protection from the live conductor and the entire system will be protected from the line conductor, and the support and then the line conductors are separated by the insulators. It provides a clearance between the main function of the insulators is to provide the insulation between the towers and then the live conductors and to prevent any kind of leakage current from the line conductors to the earth through the supports. Properties of the insulators are it should be mechanically strong, and then the main function of the insulators is to resist any kind of leakage current. Thus the insulators should have the high insulation resistance. The insulator should be free from the internal or external impurities, and it should be properly fabricated without any voids. And due to the high voltage of the conductors, there is a possibility of the flashover between the line conductors and the earth. The flashover produces an arc which will carry very high amount of heat. This may create a break or the crack, and then it may puncture the insulator also. So it should be the punctures of the insulators. So insulators must have the high ratio of puncture strength to the flashover voltage. There are certain materials which are more suitable for the insulation. They are the most suitable materials for the insulators are porcelain, glass, synthetic resin. That is the type of the insulators that what we have studied are with the different type of materials. So far we have seen the insulators with the ceramic material, that is the pin type of insulators. The different type of insulators, when we see there are different type of insulators: pin type of insulators, suspension type insulators,